So, this is the last index properties, that is a determination of the field density, that is measurement of the density on actually onto the field. Okay. So, there are three methods, from that we can find out the density of the soil sample onto the field. So, first one, that is called as a core cutter method, second one is called as a sand replacement method, third one is called as a clod method or paraffin wax method or water displacement method. So, IS code which is used for determination of the field density is IS 2720 part 28 and part 29 1975. So, so what is meant by the density? So, density of the soil sample is called as a mass per unit volume. So, this density is further divided into many categories, that is bulk density, dry density, saturated density, submerged density, density of the solids, density of the water. But here we are considering only bulk density and dry density. So, the bulk density means the density or moist density is the ratio of mass per unit of volume, and its unit is gram per centimeter cube or kg per centimeter cube or gram per ml. And this dry density is denoted by letter gamma d, while bulk density is denoted by letter rho or gamma instead of rho or gamma. So, here dry density is denoted by letter rho d. So, here we are using rho d symbol. So, dry density is the ratio of dry soil mass per unit volume of the soil sample. Okay. So, now we are discussing the first method, that is a core cutter method. So, this core cutter method, so what are the various apparatus that that are used for the determination of the field density, which is measured actually onto the ground. So, these are the three instruments, so, or we can call as apparatus. So, last one, which is called as a core cutter, which is having a height of 15 centimeter and a diameter of the 10 centimeter, and top of that is called as a cap, or which is called as a dolly. In the language of geotechnical engineering, it is called as a dolly, and the rammer, which is used for the tamping purpose. So, so this blue color we show, this is the rammer, which is used for the tamping, and this is the this is the still which is called as a, this is a core cutter. This is your core cutter, which is having sharpened edge. The sharpened edge means it's at the bottom, it is having sharpened edge, so that it can easily penetrate into the soil, and the top of that, this is called as the dolly. This is called as dolly. The height of this core cutter is 15 centimeter, and the diameter of this core cutter is 10 centimeter. Okay. So, what are the various theory for determination of the bulk density and dry density, which is measured onto the field? Okay. And what is the relation between the dry density and bulk density? Once we understood, so the method is very easy. So, so here I am using this, here I am using the symbol, that is gamma for bulk density or rho for bulk density. So, its formula is mass per unit volume, and dry density, that is gamma d, or you can call as rho d. And relation between gamma d and rho d, so gamma d and gamma is gamma d equal to gamma upon 1 plus W, where W is the water content. Okay. So, these three things are important, that is first one. First of all, we have find out the bulk density, that is mass per unit volume, so here rho, and the rho d equal to rho upon 1 plus W is a dry density. So, first of all, initially we are finding out the bulk density, then we are going to find out the dry density by using this relation. Okay. So, how we can find out this bulk density? So, by using this formula, we know that bulk density equal to mass upon bulk density equal to mass upon volume. this bulk density equal to mass upon volume. So, this volume we can easily measure this volume by using either by using scale or by using already known dimensions. So, this volume is nothing but this area multiplied by height, or we can say length. So, area, how can we find the area? So, by using this scale measure this diameter of this core cutter. As we know, the diameter of the core cutter is 10 centimeter. So, calculate the area. So, area will be pi by 4 into diameter square, that is the 10 square. We get the area, and measure the height of this core cutter. So, height is generally 15 centimeter. From that we can find out the volume of this volume of the soil sample, because we are pouring this cylinder into the soil, then how we can find the mass of the soil sample? For that purpose we have to use, so mass of the soil sample, that is, so here we know this m mass upon volume. So, this volume we already calculated by using by measuring the dimension, that is area multiplied by height, that is pi by 4 into 10 square into height is 15 centimeter. Then m m means the mass of the soil sample. It can be found out by using formula, that is m2 minus m1 upon phi. So, why I am using this formula, that is m2 minus m1, that we discuss later. So, where m2 is mass of the core cutter plus soil sample, mass of core cutter plus soil sample. Note that mass of core cutter plus soil sample, and m1 is mass of the empty core cutter. Okay. So, so we can easily find out the mass of a empty core cutter by placing this core cutter onto the balance. We can measure the mass of the core cutter. Then the second one, that is mass of core cutter plus soil. For that purpose we are going on to the field, select the area. Suppose we have selecting area approximately 30 centimeter square area. The area should be plain, which contains no any grass. Okay. Then this core cutter is placed. Suppose this is our area, then we are placing this core cutter onto that area. Then dolly is placed on this dolly, which is placed on top of this core cutter. Okay, top of this core cutter. So, by using this rammer, give the tamping until this core cutter is penetrate into the soil up to its whole depth. Okay. So, give tamping until the whole core cutter is penetrated into the soil, and note that the only 1 to 1.5 centimeter projection should be left above above the dolly, means this whole core cutter, and here is a dolly. So, it can be penetrated into the soil, and only this small amount of projection should be left, that is 1 centimeter to 1.5 centimeter. Then then we want, that is the weight, that is core cutter plus soil sample. For that purpose we can excavate the surrounding soil, so that we can get easily the whole core cutter. And then we are placing some small paper below this core cutter, so that then trimming the core cutter. So, this is our core cutter. So, by removing the core cutter, here is core cutter, and here is in between in the core cutter all the soil sample is there. Okay. Then by using trimmer, level the surface at top and bottom of the core cutter, and take the weight of the core cutter. So, it's the weight of core cutter plus soil sample. It's the weight of core cutter plus soil sample. Okay, that is we here we are getting the value of M2. So M2 minus M1. So why? So lastly, I had explained why I am using this formula, that is M2 minus M1, because we want because we want only weight or mass of soil sample, So we have the weight of, or we can call as mass of soil sample plus core cutter, mass of soil sample plus core cutter. So we have to subtract the weight of core cutter, that is weight of empty core cutter, so that we can get the only mass of soil sample, That's why we are using this formula, that is M2 minus M1 upon M2 minus M1. So M1 is the weight of empty core cutter, M2 is the weight of core cutter plus soil. Okay, from that we we are finding the bulk density, that is rho equal to mass upon volume. So mass is finding by the formula, that is M2 minus M1, and phi is our volume. Then we try to find out the dry density. So by using the relation rho d equal to rho upon 1 plus W. So rho means the bulk density, we know the value by using calculation, that is M2 minus M1 upon phi. We are finding the value of rho. Then what is meant by the W? W means our water content. So water content that can be found out by using oven drying method, that we already know. This water content that can be found out with by using oven drying method. So for that purpose, we take the soil, some part of the soil sample, and find out the water content by using formula. So we can find out the water content by using formula, that is W2 minus W3 upon W3 minus W1. So where W1 is the weight of empty container, W2 means the weight of a container plus soil sample plus soil, that is this soil, that is a sample which is collected from this core cutter that is buried onto the soil, and W3, that is the weight of core cutter plus dry soil, because we are keeping this container into the oven for 24 hours at the temperature 105 degree Celsius. From that we can find out the water content. Once we find out the water content, put the value of this water content into this formula, that is rho d equal to rho upon 1 plus W. From that we can find out the value of dry density. Okay, easy understanding. I will show what are the various observations table that we are using. That is, first of all, the determination number, that is how many sample we have collected or we were taken, that is called as a determination number. Then first of all, this is MC, that is mass of empty core cutter. Here MC, so here we were calling as MC as M2. MC means our MC is our M1. And then the mass of core cutter plus wet soil. So this mass of core cutter plus wet soil we will obtain after when we collect the soil core cutter after when we collect the core cutter after digging the excavating the surrounding soil and measuring the weight of the core cutter into the laboratory, into the into weighing balance. That is our M2, and this is our M1. That is then mass of wet soil, that is total formula, that is M2 minus M1, that is equal to M. So this is our M. Then the volume of core cutter, that can be measured by measuring the diameter. From the diameter we can get the area and multiply by height, we give the volume. Okay, then the bulk density is obtained, that is mass upon volume. Okay, then the following are the calculations for the water content determination. So first one, that is a weight of empty container, that is M1. So here is called as M1, or here we can call as W1. then the weight of container plus wet soil, that is W2, then the weight of container plus dry soil, that is W3, and the formula will be, here is M2, so we can use W2, and M3 means W3 upon W3 minus W1 into 100, and the dry density, the formula is bulk density upon 1 plus W, that is rho upon 1 plus W. So this W is calculated. Okay, so this is the first test. From that we can find the bulk density actually onto the field. Okay, thank you.